SpaceX tests a flight-proven Super Heavy booster for the first time, we've got breathtaking views from the first crewed flight in polar orbit, and Jared Isaacman will soon have his Senate confirmation hearing for NASA Administrator. As always, we'll have all that and more coming up this week in Spaceflight. It's not every episode that we cover a crewed flight with a lot of firsts, but with From 2, which happened this week, it's definitely one of those times. From 2 started off with Falcon 9 and Crew Dragon Resilience lifting off on April 1st at 1:46 UTC from Launch Complex 39A at the Kennedy Space Center in Florida. The first of the mission actually came with the launch of this capsule and crew being inserted into a polar orbit around the Earth. This marked the first time ever that a crewed flight has gone directly over the poles, going into an exact 90-degree inclination in low Earth orbit. This orbit offers a view that no other space traveler has ever seen before. Until now, the crewed missions with the highest orbital inclinations happened during the Vostok and Voskhod flights by the Soviet Union in the 1960s, all of them at a roughly 65-degree orbital inclination. From the US, the highest inclination for a crewed flight was on the STS-36 mission, which achieved a 62-degree inclination orbit thanks to a dogleg performed by the space shuttle during its ascent. This means that until From 2, no other crewed flight was able to fly over the poles. But the uniqueness of this orbit isn't just the trajectory. The higher orbital inclination also means that the crew receives a slightly higher dose of radiation than the orbit of, say, the International Space Station. This mainly stems from the fact that the spacecraft flies over the Earth's magnetic poles, where the magnetic lines bring highly charged particles closer to the Earth's surface. This is in part why we see auroras here on Earth, since those particles interact with the upper atmosphere. That being said, the crew is definitely not spending months up there like crews do on the ISS, so their overall accumulated radiation exposure will be a lot lower. This type of orbit also provides SpaceX with experience launching crews to different orbital inclinations. Up until now, SpaceX has launched Crew Dragon missions to 51.6-degree inclination orbits, which is the same orbital inclination as the ISS. This was done even on the free-flying missions like Inspiration 4 and Polaris Dawn in order to take advantage of the abort zones and mission planning already performed for ISS-bound missions. Launching to this unique polar orbit meant that SpaceX had to take into account different abort zones, weather conditions, launch timings, and many other constraints. For example, to get into orbit from Florida, Falcon 9 had to launch southeast and then veer south around the Florida coast to avoid land. This is something that we've seen before on several satellite missions, but not with Crew Dragon on top. This means mission planners had to integrate abort modes on Dragon to avoid certain areas like Cuba or Panama. But Crew Dragon isn't made to land on land, so if it had to abort at a point in the flight where it could possibly end up in Cuba or Panama, the capsule had the option to turn around and fire backwards to boost back and splash down into the ocean rather than hitting hard ground. This also ended up affecting the rocket's flight profile as well. Lately on Crew Dragon flights, SpaceX has been able to squeeze out enough performance to land the booster back on land. But with this demanding flight profile, a return to launch site just wasn't in the cards. That said, SpaceX still reserved some leftover performance to do a short boost back burn on the Falcon 9 booster so that it didn't end up landing in Bahamian waters. And yes, while SpaceX did land a booster on Bahamian waters just over a month ago, officials confirmed during a pre-launch conference that they wanted to perform more environmental studies before committing to landing more boosters in that area. Hence, the need for that change. On board Resilience for this mission were Mission Commander Chun Wang, Vehicle Commander Yannicka Mikkelsen, Vehicle Pilot Rabia Raga, and Mission Specialist and Medical Officer Eric Phillips. Wang, Chinese-born but with Maltese citizenship, is an entrepreneur and cryptocurrency investor who co-founded F2 Pool and Stakefish. He's also an avid traveler here on Earth and off Earth as well, with From 2 marking his 1,000th flight of any type. He funded the mission and selected an international crew that he'd already met through his previous adventures. Mikkelsen is Scottish-born but has Norwegian citizenship and thus carries Norway's flag for this mission. She's a cinematographer and film director who participated as videographer on the One More Orbit round-the-world flight from pole to pole. You may have even seen her in some of the shots from inside Dragon, using her camera skills while in orbit to film views from Resilience of the poles. Raga is a robotics researcher from Germany, holds a master's degree in electrical engineering, and is currently pursuing a PhD in Norway. As part of her research work, she's traveled to the Arctic on several occasions, studying ways that robots can navigate in extreme environments. Finally, Phillips is an Australian adventurer and polar explorer who's had numerous expeditions to the North and South Poles and is co-founder of the International Polar Guides Association. The crew has been sharing pictures and videos from inside Resilience, which, just like Polaris Dawn, had a trunk fitted with a Starlink placer, allowing the crew to have gigabit connectivity by connecting directly to Starlink's laser network.
What are you doing, Eric?
Sorry, John. Well, I'm having a conference call, like you do from space,
Eric,
right?
Yeah, Eric's calling for what?
I'm talking to my son.
Yeah, talking to our son.
Resilience has also been fitted with a cupola, just like on Inspiration 4, allowing the crew to share some truly amazing videos of the Earth while in orbit. Wong also shared that the entire crew succumbed to space sickness during the first day, but that it went away on the second day of the mission. You know, it happens to the best of us, right? But this trip isn't just about phenomenal views of the Earth. During their stay in orbit, the crew has conducted several research experiments, including taking the first X-ray images of the human body while in orbit. Another study was the unassisted egress of the crew out of the capsule, which will help characterize the ability of astronauts to perform unassisted tasks in future missions to the Moon or Mars. The mission returned to Earth after a few days in space, mainly because free-flying Dragons don't have the benefit of being docked to a massive space station to supply consumables to keep the crew alive for prolonged periods of time. Notably, this return marks the first time that a Crew Dragon capsule has landed on the West Coast, with Resilience splashing down off the coast of Southern California, very close to SpaceX's Hawthorne facilities. Safe to say, this crew of 4 will now have a lot more to share after this mission. Blue Origin's New Glenn rocket is one step closer to its next launch. Just a few days ago, the company announced that it submitted its final mishap report to the Federal Aviation Administration regarding New Glenn's first booster landing attempt. Now, this flight, which took place back in January, successfully demonstrated New Glenn's ability to place a payload into orbit with a successful ascent of the booster and the 2 planned burns of the second stage. The booster landing, however, was always understood as highly experimental, with a high likelihood of failure. As a result, it was no surprise that, in the end, the first New Glenn booster, named So You're Telling Me There's a Chance, ultimately failed during its entry and landing attempt on Blue Origin's Jacqueline drone ship. The booster landing failure triggered a mishap investigation that the company has finally completed and that the FAA has now signed off on. The agency stated that, quote, "The final mishap report identified the proximate cause of the mishap as an inability of New Glenn's first stage to restart the engines, preventing a re-entry burn from occurring, and resulting in the loss of the stage." Blue Origin says that the report identifies 7 corrective actions, focusing on propellant management and engine bleed control improvements. This is a bit vague, but it kind of sounds like there was some sort of problem with the propellant systems during the re-entry burn, maybe too much sloshing or something similar, that prevented the correct relight of the BE-4 engines for the re-entry burn. The mention of engine bleed control improvements is also interesting, as it may indicate an issue with the engine chill ahead of entry burn. With the report complete, Blue now says that it's aiming for a second flight of New Glenn in late spring, and FCC permits suggest that the company may soon start testing the second stage of that New Glenn in a matter of days. We'll definitely keep an eye on that work ahead of the flight. Now, along with the news of the New Glenn mishap report being completed and signed off by the FAA, the agency also announced that it signed off on the mishap report for Starship's 7th flight. This flight also took place in January and featured the first flight of a Block 2 ship as the upper stage of Starship. Now, as you probably know by now, this mission ended short of its goals, with the ship failing during its ascent burn and debris raining down in the Caribbean. As a result, SpaceX had to complete a mishap report for this mission and identify the cause of the failure. SpaceX released a preliminary conclusion of this report back in February in anticipation for Starship's 8th flight, indicating that Flight 7 had suffered higher harmonic responses than previously thought. This led to higher stresses of the propulsion hardware, which produced leaks, and the leaks then turned into fires, and the fires turned into the engines going boom, and the flight ultimately being terminated. On the FAA's statement about the Flight 7 mishap investigation, it states that, quote, "SpaceX identified 11 corrective actions to prevent a recurrence of the event. The FAA verified that SpaceX implemented corrective actions prior to Flight 8. I guess SpaceX then later verified that said corrective actions might not have worked. Flight 8, very much like Flight 7, ended short of its goals as well, with what appeared to be another fire in the engine bay and exploding Raptor engines. Now, it's not for sure that both flights were hit with the same failures, but it's pretty easy to draw some parallels. Now, while the ship end of Starship has had quite a rough time lately, the boosters have actually been hitting all the marks. marks, with SpaceX catching boosters 3 times out of the 4 attempts so far. One of them, Booster 14, even just fired up at the launch site in preparation for its next flight, marking the first time that a flight-proven Super Heavy vehicle has been tested after flight. SpaceX later confirmed that Booster 14 will be reflown on the upcoming 9th flight of Starship, the first reflight of a Super Heavy booster. The company also confirmed that 29 out of its 33 engines have previously flown as well. While far from their rapid reusability goal, this first reflight is still happening much faster than the first reflight of a Falcon 9 booster, aided in part by the fact that SpaceX doesn't need to wait on a customer to accept to fly on it, since Starship doesn't carry any customers yet. Over time, Falcon 9 reusability has seen turnaround times drop pretty substantially, with the current record turnaround set at under 10 days for a Falcon booster. It may take some time, but one day, that could also be Super Heavy's reality. With all of the launches we cover on this show every week, it feels like it's getting kind of crowded up there. Unfortunately, the vast majority of the objects in orbit around Earth aren't useful satellites, but rather pieces of junk in all shapes and sizes, and these can cause some real trouble. Currently, there are about 40,000 objects being tracked in orbit, and only 11,000 of them are active satellites. However, these are only what's big enough to track. It's estimated there might even be over 1.2 million objects larger than a centimeter. Now yes, a centimeter's small, but you have to remember all of these objects are moving at orbital velocities. That incredible speed means that even just a tiny piece of debris can still cause quite a lot of damage if it collides with a satellite. Well, the European Space Agency is worried about it too, and this week the agency released its Space Environment Report for 2025. It's a 144-page report with a lot of graphs detailing everything that's going on in Earth's orbit and how it's changed over time. The agency's Space Debris Office has been releasing this report every year since 2017, and this year's edition contains some good news, but unfortunately also some bad news. Let's start with the good news first. The number of intact reentries went up this year, which means that an increasing number of satellites are being disposed of properly. But it's not just satellites. Another big contributor to space debris is spent rocket stages. They're often pacified and parked in graveyard orbits, but those plans don't always work out, and sometimes they break up and leave lots of debris. In fact, we've covered a few of these events in previous episodes. We're currently working on a video about how rocket stages are disposed of and how they can contribute to space debris, so subscribe to be sure that you don't miss it. Fortunately, the situation is getting better. For the first time ever, controlled reentries of rocket stages outnumbered the uncontrolled ones in 2024. And that's fantastic! But it's to be expected as more and more launch providers are properly disposing of their rockets, and satellite operators are doing the same with their satellites. So, problem solved? Well, remember when I said that there was also some bad news too? Despite all of these measures taken by launch providers and satellite operators around the world, 2024 still saw a net increase in space debris. Even if we completely stop launching today, ESA still expects that the amount of space debris will increase. After all, any collision up there will likely cause more debris, which will then cause more collisions, and so on and so forth. This runaway effect is known as the Kessler syndrome, and it could actually make spaceflight impossible. So ESA concluded that just preventing space debris isn't enough. We need to actively clean up the mess. And that's where the final bit of good news comes in. Space agencies around the world are working on this problem. ESA's planning to launch a cleanup demonstration mission called Clear Space 1 in a few years, and the Japan Aerospace Exploration Agency is working on similar plans. In fact, we followed the ADRAS-J demonstration mission for that last year. Hopefully, space debris will get more and more attention from other agencies and the space industry as a whole, and maybe in a few years we'll get a report that's only good news. Now we'll take a look at some other stories across space, starting with the United States Senate. This week, the Senate Commerce Committee scheduled the confirmation hearing for Jared Isaacman for April 9th at 10 a.m. Eastern. That'll be 1400 UTC. President Donald Trump announced Isaacman as his pick for the next NASA administrator back in December, formally nominating him in January after the president's inauguration. The U.S. Senate had to first go through several other nominations for Trump's cabinet before reaching the heads of organizations like NASA, which is why it's taken a few months to reach this point. Isaacman's nomination was recently supported by several former astronauts in a letter sent to the Senate urging lawmakers to swiftly approve his nomination. Barring any surprises, he's expected to be approved by the committee and confirmed as the 15th NASA administrator. And if you want to learn more about how NASA's budget and spending has changed over time, and how the Isaacman administration could shift the agency towards a more commercial and cost-effective future, make sure to keep an eye out around the time of that confirmation hearing, because we're working on a video about exactly that. This week, NASA announced who will be flying on the next crew rotation flight to the ISS from US soil. Crew 11 is currently set to fly to the International Space Station no earlier than this coming July on Crew Dragon Endeavour. The commander will be NASA's Zena Cardman, making her first spaceflight, with fellow NASA astronaut Mike Fink, the mission's pilot, who will be making his fourth spaceflight. As for the 2 mission specialists, JAXA's Kimia Yui will be making his second flight to the station, and Roscosmos' Oleg Platonov, like Cardman, is a space rookie. Cardman and Fink were both supposed to fly on other flights, but the issues plaguing Starliner's crew test flight had far-reaching effects on crew assignments. Cardman was originally assigned as commander of Crew 9, but was left behind when it was retasked to incorporate Sunny and Butch from Starliner. Mike Fink was supposed to fly on Starliner 1, the first operational flight of that spacecraft, but as the whole Starliner program is essentially up in the air now, so to speak, he's been moved to Crew 11. NASA and Roscosmos also announced the crew complement for the crew flight after Crew 11, Soyuz MS-28. NASA's Chris Williams, a physicist and medical researcher, will make his first spaceflight on MS-28 this November, joining Roscosmos' Sergei Kuzverchkov, a space veteran, and fellow space rookie Sergei Mikhaev. We've just received the first images from NASA's latest space telescope, the Spectrophotometer for the History of the Universe, Epoch of Reionization and Ice's Explorer, or SPHEREx. It's quite a mouthful, isn't it? SPHEREx, along with another NASA mission, Punch, was launched back on March 11th from Vandenberg Space Force Base in California. From its perch in sun-synchronous orbit, SPHEREx sent back 6 images of the same star field in the sky as part of the commissioning process before beginning routine science operations later this month. These 6 images correspond to each of the observatory's 6 detectors, which observe in different parts of the infrared spectrum in wavelengths that we can't see from Earth. The light is broken up into 102 individual colors, which can tell us a lot about each object. The star field seen here is also 20 times wider than the full moon, so that's a lot of data in one go. SPHEREx complements existing space telescopes by delivering a much wider view of the sky. Its results can also be used before pointing larger telescopes like Hubble or Webb towards specific objects to zoom in for a much closer, much more detailed view. SPHEREx is able to cool its infrared detectors to -210 degrees Celsius using an innovative passive cooling system that doesn't use coolant. With this capability, SPHEREx is scheduled to spend at least the next 2 years on its primary mission of observing hundreds of millions of stars and galaxies in an unprecedented all-sky infrared survey. The European Space Agency has contracted Airbus in the UK to design and build its Rosalind Franklin Mars landing platform. The ExoMars project will search for life below the surface of the red planet with the help of a European-built rover, but that rover has had quite a bumpy road well before landing on Mars. The original partnership between the agency and Roscosmos included a Russian-built landing platform launching on a Russian Proton rocket, but plans were changed quite a bit following the invasion of Ukraine in 2022. Airbus will now design the landing platform, including the propulsion and braking system that will guide the craft through its critical 6 minutes of descent. Rosalind Franklin will be Europe's first Mars rover, and 2 ramps on the lander will give it options to disembark. A 2-meter drill on board will also reach layers underground that have been protected from surface temperatures and cosmic radiation, which the rover will be able to study in situ. If there ever has been life on Mars, this should give us a shot at finding it. NASA will provide the ride to space, taking advantage of the 2028 Mars transfer window. The mission will be Europe's 3rd attempt to soft land on Mars, and hopefully its first successful one, touching down on the surface in 2030. Okay, you might recall a recent story of a near-Earth asteroid that briefly posed a risk of impacting the Earth in 2032. Well, it's back. Okay, well, it hasn't reached us yet, but it's back in the news because scientists now think that it has a slim chance of colliding with the moon. Asteroid 2024 YR4 was first detected in late December, and limited data initially put the chances of impacting Earth as high as 3%. Additional data in late February allowed that risk to be recalculated down to 0.004%, and then NASA officially declared that the asteroid posed no significant threat to Earth for the next century. Phew! Now, new infrared observations by the James Webb Space Telescope have estimated the size of the asteroid to be around 60 meters across. roughly the size of a 15-story building. However, those observations have now led to new estimates suggesting a 3.8% chance that the asteroid might strike the moon instead of the Earth in late December 2032. We'll know more when Webb conducts further observations in May. But don't worry, if it did impact the moon, the collision wouldn't be enough to change its orbit. Although I guess it would be kind of cool to see from the Earth for a little bit. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. Starting off the week on March 29th, we had a partial solar eclipse on Earth. The path of maximum eclipse started in the middle of the Atlantic Ocean, crossed northern Canada, and finished in Russia after passing near the North Pole. While the maximum eclipse may have only been visible over sparsely populated areas, many across the northern hemisphere still got quite a show, as the eclipse was visible in Europe and western Russia, as well as Canada, Greenland, and the northeast of the United States. Did you get to see the eclipse? Let us know in the comments. Now on to launches, starting with one from China. On March 29th at 16:05 UTC, a Changzheng 7A took off from the Wenchang Space Launch Site. The payload on this mission was a classified satellite, reportedly on a mission to test multi-band high-speed satellite communication. The rocket deployed it into a geosynchronous transfer orbit. Over in Norway, we had the first ever launch of the Spectrum rocket from Isar Aerospace. The German company developed and built the rocket to carry up to 1,000 kilograms of payload into low Earth orbit, and this week, Spectrum was finally ready to light its 9 propane-powered first-stage engines for its inaugural flight. On March 30th, the rocket roared to life and lifted off from the pad on Andoya Island at 10:30 UTC. The rocket successfully rose into the sky and cleared the launch pad, but unfortunately, Spectrum lost attitude control around the time of the planned pitch-over maneuver. The flight was terminated soon thereafter at 30 seconds into the mission, and Spectrum fell into the sea below. Despite the less than ideal ending, Isar is still happy with the result. It may have been short, but Spectrum's flight met all of Isar's goals, and the company got a lot of data to use for improving their upcoming vehicles. The launch pad also came away unscathed, and with the second and third rockets already in production, Isar wants to be back out there as soon as possible. Hopefully the next one gets a little further off the ground. Next up, we had a Starlink mission from Florida on March 31st. Falcon 9 lifted off from the Cape at 1952 Universal Time, and with the successful delivery of 28 Starlink V2 mini satellites into low Earth orbit, it also completed the 100th successful Falcon mission since the previous failure in July of last year. Continuing that success, booster B1080 wrapped up its 17th flight by touching down on the deck of drone ship Just Read the Instructions. This Starlink launch was the 26th mission of the month of March. Unfortunately, 2 of them were not successful. The first of these failures was the Kuaizhou 1A that reportedly exploded at liftoff in China early in the month, and the second was the Spectrum launch this week. That said, the 26 launches this month bring the worldwide tally up to 67 in 2025. Of these, 36 were performed by SpaceX's Falcon 9, which as usual is followed by China with a total of 17 missions so far this year. Back in China, we had a Changzheng 2D launch from Zhochuan on April 1st. Lifting off at 4 o'clock Universal Time, the rocket carried 4 payloads into low Earth orbit. The 4 satellites are meant to demonstrate satellite internet technology, which might even include testing direct-to-cell mobile broadband connections. The next launch also occurred in China, but this time at the Taiyuan Satellite Launch Center. On April 3rd, a Changzheng 6 lifted off at 2:12 UTC to send a single payload into low Earth orbit. The satellite will be used as a calibration target for ground-based satellite tracking systems, which will help to improve orbit prediction models. And wrapping up the week, Falcon 9 launched a Starlink mission on April 4th. This flight delivered 27 Starlink V2 mini satellites to space. SpaceX used booster B1088 for this mission, which ended its 5th flight by successfully touching down on the deck of drone ship Of Course I Still Love You. This was the 3rd launch of this booster in just 23 days, which says quite a bit about the level of rapid reusability that we've reached with Falcon 9. With the 2 Starlink missions this week, SpaceX has now launched a total of 8,213 Starlink satellites, of which 1,038 have re-entered, and 6,467 are now in their operational orbit. Next week, we'll have the launch of the Soyuz MS-27 mission to the International Space Station. Liftoff is scheduled on April 8th at 5:47 UTC, and on board the spacecraft will be Russian cosmonaut Sergei Ryzhikov, the commander, who will be flying to space for the 3rd time. He will be joined by cosmonaut Alexei Zubritsky and NASA astronaut Johnny Kim, both first-time flyers. The trio is scheduled to stay on the station until December, replacing the Soyuz MS-26 crew, who've been up there for nearly 200 days. The MS-26 crew of cosmonauts Alexei Ovchinin and Ivan Wagner and NASA astronaut Don Pettit will depart the station later this month. We'll also have 2 Starlink launches and the very first launch for Amazon's Kuiper constellation of internet satellites next week. Check out NSF's next Spaceflight app to stay up to date with these and other launches and spaceflight events. The app recently got an update with a flight simulation feature in partnership with Flight Club, which allows you to follow the flight's trajectory before and during the launch. It's really cool, you should try it. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.